Hey gang, I hope you're doing well. This is just a great set of notes reviewing what we've done the last 3 days in algebra review. Guys, you've been great. I hope those of you who enjoy algebra, this has been helpful, reviewing and getting you ready for next year. I'd also encourage you to start reviewing for your finals. But right now, let's do some review and see if you guys remember a little bit of what we've been covering before and after your Unit 11 test. Well, first things first, we got to simplify radicals, and I'm not gonna use the prime factorization method. It just takes too much time, but it is a method if you want to use to simplify that works really great. But instead, I'm going to use the fact I'm taking out my largest perfect square numbers that I can. And so we remember to look at a radical. That -3 stays on the outside. We have to multiply whatever we take out of our radicals to that. But first, remember the first one on the left is all my perfect squares. The one on the right is what does not have a perfect square. So what's factored out that's not a perfect square. So I look at 125, and I know 25 is my perfect square number that I can factor out of 125, which leaves a 5. Then I look at x squared. Remember, if it's an even exponent, it's a perfect square number. So x squared comes out. Then I have y to the 7th. Well, y to the 7th is not a perfect square. However, we know if we have 1 less, y to the 6th it is. So then I have a y left. And then we also have z to the 1st. It's not a perfect square number, so it gets left underneath the radical sign on the right. And then we take the square root of it. So what's the square root of 25? Well, that's 5. The square root of x squared is x. The square root of y to the 6th is y cubed. And then your radical, square root of 5yz, comes along. Then you have to take the time and multiply it to the 3. So now I have a -3 times 5xy cubed, which gives me a -15xy cubed times the square root of 5yz. You guys remember doing this a little bit more now? Good. Now, what happens if I multiply two radicals? Well, if I multiply two radicals, remember you multiply the numbers out front together, and you multiply the numbers underneath together. Well, there's the numbers out front are 1 and 1, so that leaves us as 1. And the number underneath gives us 576 when we multiply them together. Well, what's the square root of 576? Well, it's a perfect square. It is 24. Not too bad. A lot of times we encourage you when you're multiplying radicals to go ahead and multiply them and then simplify. Then we have our next one. Again, I'm going to be pulling out my perfect square numbers. Well, the 5x stays out front. We're good with that. But what is the perfect square number that I can take out of 300? Well, if it's ever you have hundreds, all right, so like 100, 200, 300. We know 100 is a perfect square. So I can take out a 100, which leaves 3 on the right because 100 times 3 is 300. We have an x cubed, which means that's odd, but I can take 1 less to get x squared, and then I leave an x underneath the radical because remember x squared times x is x cubed. And then we have our y. Now, let's simplify. What's the square root of 100? Well, that's 10. What's the square root of x squared? Well, that's x. Oops, guys, I put the y in the wrong spot earlier. Forgive me. The y needs to go on the other side because it's not a perfect square. All right, so then we get our 10x. Then we leave our radical, 3xy there. So what's 5x times 10x, guys? It's 50x squared times the square root of 3xy. Hopefully that makes a little bit more sense. All right, let's do one last one, which is a little bit simpler. We have a -5 here. I still am going to take out my perfect square numbers. Well, the perfect square number that comes out of 54 is 9. So you're left with 6. Then I have z to the 6. Well, that's an even numbered exponent, so it's a perfect square. So now look what we have here. We have a -5 times the square root of 9z to the 6. Those are my perfect square numbers, times the square root of 6, which does not have any factors that are perfect square numbers. So then I get -5 times 3 times z cubed times the square root of 6. What's a -5 times 3? It's a -15 z cubed times the square root of 6. All right, what do you guys think? Does it make sense? Great. All right, last thing that we learned. we reviewed factoring. And remember with factoring, it's not that bad. We just need to remember the steps. What's the first thing you always look for? You always look for a greatest common factor, or GCF. So greatest common factor. So you always have to factor that out. If you don't factor out greatest common factors, you're not completely factored. So a quick example of this would be a problem like this. We have 7x squared minus 14x cubed. All right, so with that, what do we factor out? We take out a 7x squared. Well, what's 7x squared divided by 7x squared? Well, that's 1. What's 14x cubed divided by 7x squared? Would that leave a 2x? Now that's a completely factored problem. Now remember, when you're factoring out a greatest common factor, it's like you're undistributing. Instead of multiplying, you're going to be dividing things out. So hopefully that made a little bit more sense. Then we talked about if you have just two terms in your problem, in your algebraic expression that you're trying to factor, you always want to look for the difference of two squares. I believe Mrs. Prempus had that in her video the other day when you had to watch about through 10 minutes of it. So the difference of two squares. So let me give you an example of that. A difference of two squares would be a problem like this. 16x squared minus, let's say, 49. Well, it's just two terms, and then the two terms, if you notice, they're both perfect squares. And a difference means subtraction. So 16x squared minus 49 is a difference of two squares. So the next thing you know you're going to do is you're going to go to your two sets of parentheses. And when you have a difference of two squares, you always have one positive, one negative. Then you take the square root of each term. So the square root of 16x squared, well, that's going to be 4x. So I got 4x and 4x. The square root of 49, well, that's 7 and 7. Now, how do we know if we're right? Well, you can always still OI. Again, negative 28x, positive 28x. What do they add together to be? 0. So there's no middle term. We did that totally correct. And remember, those have a special name as binomials. Those are called conjugate binomials. All right, let's try another difference of two squares. I get here 8x squared minus 50. Now, if you look at that, you're like, there's no perfect squares. What are you supposed to do first when you factor? That's right, you've got to take out a greatest common factor. So if I take out 2, I get 4x squared minus 25. Now I have a difference of two squares. I get a plus or minus on the inside. What's the square root of 4x squared? 2x. 2x. Square root of 25? 5 and 5. And if we OI it, it'd work out perfectly. Remember, your final answer does have to include the 2. All right, so we reviewed a lot of stuff. We're not quite there yet, but we're almost. So let's do a couple more factoring. What happens if we have three terms? When you have three terms, you're going to use what's called logical guess and check. I do believe Mrs. Prempus called it in the video from the Algebra 3 video. We're going to call it trial and error. It means the same thing. Her and I just have two different terms for that. Actually, I think I'm going to move my trial and error here. Call it over there. So trial and error. Or logical guess and check. All right, now what do we mean by three terms? Well, how about if we had a problem like this? 20x squared, oops, there should be a 20 there, plus 23x plus 6. Well, what's the first thing you always check? Well, you always check if it has a greatest common factor. Well, this one doesn't. Then you do your two sets of parentheses, and we check our signs. Same sign, both addition. So we have a plus and a plus. All right, now we need to think about what numbers are factors of 20. Well, we know that we're going to have 1 and 20, 2 and 10, 4 and 5. Which one's the most logical ones to use? That's right, 4x and 5x. All right, then we have our factors of 6, 1 and 6, 2 and 3. Which ones do you think we should try? 2, and 3, right? We try the ones closest together first. Now, can I put the 2 with the 4? And the answer is no, because 4x plus 2 would then have a greatest common factor. And I can't have any greatest common factors because my original problem had no greatest common factors. So we know the 3 would have to go here. The 2 would have to go with the 5. Then how do we check if we guessed correctly? Well, you do OI. Take the outside. 4x plus 2x is 8x. I do the inside. What's 3x plus 5x? Well, that's 15x. Well, 8x plus 15x equals 23x. Well, that means we did it right. So my final answer is going to be 4x plus 3 times the quantity 5x plus 2. And if you really wanted to overcheck, like overkill check, you could always FOIL out the whole thing to see if you're right. All right, let's try one other example, and then we're going to do some solving equations. All right, another example that we have. How about if we had 2x squared minus 12x plus 18? All right, guys, what's the number one thing you got to look for? Number one thing. Greatest common factor. Now, you're all supposed to say that out loud at the same time. Greatest common factor. Except for I've asked you to use earbuds while you're doing this, so probably not the best. But greatest common factor is going to be 2 here. So if I factor it out, remember this is what we're going to have. Then we do our 2 sets of parentheses. Now, with this one, again, check your signs. Same sign, both subtraction. So we have x, x. Well, what's the square root of 9, guys? Or what 2 numbers multiply together to be 9 that give you 6? Well, that'd be 3 and 3. And you can double check again. Negative 3x outside, negative 3x. Well, negative 3x plus negative 3x, negative 6x. We have it correct. Don't forget you need the 2. You could also write it, if you wanted to, as 2 times the quantity, x minus 3 squared. That's another way of saying the same thing. All right, last 3 examples. Solving equations. We haven't spent a lot of time talking about them, but I feel like you guys would do a pretty good job anyway. Well, the first one I want you to do is this equation. Y plus 3 over 5 equals y minus 3 over 4. So what are we going to do? We are going to cross multiply. So I get 4 times the quantity y plus 3 equals 5 times the quantity y minus 3. Remember, if 2 fractions are equal, cross multiply, or fancy term, cross products. The product of the means equal the product of the extremes. So let's distribute. So you got your 4y plus 12. Get your 5 going across this time. So 5y minus 15. All right, let's put like terms together. I'm going to subtract the 4y from both sides, which gives you y. And then add 15 to both sides. You get 27 is equal to y. What do you guys think? It's not too bad, is it? That's what I thought. All right, now one thing that I haven't asked you to do, but something that I expect you to do, is to work with what are called inequalities. Now remember, inequalities are really the same thing as equations, except for you have just one side of that is true. You don't have this line that goes on forever. It's really just like just one side of a line. But you treat the same way unless you multiply or divide by negative numbers. So let's solve this one and I'll try to review that with you. Well, how do I solve this equation? Well, you still want to isolate the x. So the first thing you're going to do is going to subtract 5 from both sides. So then you get negative 4/5 x is greater than negative 2. Then the next thing you're going to do is you're going to multiply both sides by 5. And the reason why I want to do that is I want to get rid of my fraction here. So I get a negative 4x is greater than a negative 10. Now I need to solve for x. And then you have it divide by negative 4. Now, anytime that you multiply or divide by a negative number with inequalities, I tell people to circle your inequality. And that's your sign that you're supposed to change its direction. And then when you do that, you solve, you get x is less than, and then you reduce the fraction, negative 10 over negative 4, which would be 5/2. So remember, if you multiply and divide by a negative number, then you switch directions, but that's the only time. Otherwise, you treat inequalities exactly the same way as equations. All right, last equation for number 3. We're going to have the following. Negative 3 times the quantity x minus 4 plus 2 times the quantity x minus 7 equals 33. Now remember the rules. You cannot, if you guys remember on this one, you cannot move sides of the equation until you simplify. So when I do this, I'm going to distribute my negative 3 to get rid of my parentheses. So again, negative 3x plus 12. We're going to distribute the 2. So I get positive 2x minus 14 equals 33. We're going to combine like terms. So again, negative x minus 2 is equal to 33. Add 2 to both sides. And then we divide both sides by negative 1. X is going to equal negative 35. All right, so guys, now the rest of this class period, which should be about the last 15 minutes or so, please take the time to work by yourself or with a partner on your homework that is due on Monday. So don't forget to do your algebra review. It's online. It's algebra review day 4. You guys will do great.